Hello and welcome back. Today not on the bench but soon to be back on the bench is the 2634 20 watt class AB2 push pull amplifier. And if you watched the last video, sorry about the jiggery, if you watched the last video you saw that I tried my hardest to try and alleviate hum. So I'm going to point you at one of the speakers. I am hoping you can hear that. So it's much reduced, and then there's this one. That one is quiet as a mouse. So this speaker here is the left speaker, and that's the one with the DC power supply going to the EF37A. So there is a little bit of difference. So now what I'm going to do, I'm going to turn the volume straight up. Now we're going to go and listen to the right. As you can hear, it's quite noticeable. And we'll go and have a look, listen, sorry, with the left one. So it's still noticeable. Now I'm going to play a bit of music, and hopefully you can sort of get an idea of what it actually sounds like. One moment. This is the same track that I used last time. Woke up this morning and I laid back my head. I'm going to point the microphone at the speaker. Thought yesterday and all that you said. Oh, you're looking as flat. Oh, honey. Let me sit down in my chair. So the hum problem is still there. It's a lot less than it was, however, to me it's still a problem. I mean, this is sort of one of my listening chairs, and I can hear it from here, and that isn't with the volume controls up at all. They're at 0. And the other thing that I've noticed is that the music is a bit sterile. There's too much negative feedback, I think, making the music, I mean, it's alright and everything, but it doesn't sort of set, you know, it doesn't get the doesn't make your hair stand on end sort of thing. It doesn't make you smile. So we still need to do some more work. So let us go into the workshop and I'll show you what I'm going to try. I'm hoping you can see that. So what we've got, I'll just go through it but simply. What we've got is our EF37A providing a lot of gain. That then goes into a long tail pair which has a constant current sink in its tail, as it were. That then goes on to a couple of cathode followers which are direct coupled to our output valves, so that we can bias them and drive them into class AB2 to get usable amount of power output. As you can see here, this here from here to here is symmetrical. The long tail pairs, a differential pair, have very good common mode ratio rejection. What does that mean? A long tail pair, or a differential input stage, how it operates when it's not in a phase splitter sort of type, you know, not configured as a phase splitter. What it does, basically we've got two triodes connected together, and what it does, it amplifies the difference between what it sees on this grid here and this grid here. So if we've got 50 Hertz here and 50 Hertz here of the same phase and everything, then it should reject that for the most part and not pass it on. The EF37A, being a single-ended sort of class A sort of McGubbins, hasn't got very good common rejection ratio. So this is my idea. So my idea is to make the input, instead of that EF37A, is to make it a balanced input like here, so that it's balanced all the way through, and in theory that should give us a lot better common mode rejection ratio than what we had before. However, one thing it will also do though, it will reduce the gain a hell of a lot. A long tail pair or a differential input stage, especially in this configuration, if we was to take the output like here and here, then we would, you know, get sort of quite a bit of gain. But because like it's configured like this, we'll get about half the amount of gain, and so that, you know, there's going to be a problem there. I wish I could stop jigging about. The other problem is that normally what would happen is, instead of right, we will also need as well, if I just find the pen which I forgot to draw on, we'll need some way here of putting in an out of phase signal here like that for it to work. So that means we're going to need a balanced output from a preamp or something. Not too difficult to do. However, it, you know, sort of complicates matter. Also, the problem is, where do you apply negative feedback? I'm not too sure about this. It's not like normally you put your negative feedback like here, going in to your first, you know, V1 first stage as it were, into its cathode for a voltage divider. Well, I haven't done this before. There. Normally the way you would apply negative feedback in a differential input stage is you would only feed the signal in one triode, and instead of putting a signal here from the input, you would put your negative feedback into this triode here, and that's how you would do it. However, we can't do that because we're using both of the grids, both of the triodes as inputs. So yeah, a lot to work out. Right, sometime later, a few days later, I've taken out the components for the EF37A pentode and not bodged exactly, but put in the components needed for a 6H8C at the moment, differential long tail pair, whatever you like to call it, with a constant current source. This is just a constant current source I just knocked up. It's the same as the one on the schematic. And then what we've got here is two 2K2 resistors, which I just had lying on the bench, and they're just acting as grid stoppers at the moment, and just a sort of convenient place where I can connect my signal generator, which is this one, which has a balanced output. Well, I've applied some negative feedback, and that's with 0 volts going in, and it's not, I mean, it's not very good. This is a sod, this amp is. Well, I admit defeat. I have tried everything, and been at this a long time to try and solve the hum issue. Nah, can't do it, and I'm pretty damn certain I know why, which means a lot more work. I'm just not minded to do that at the moment. One thing I did try doing was I had this idea, because we've got a transformer here that's maybe, because these are microphonic, maybe, you know, the sort of 50 hertz hum was sort of getting into the valve through the base. So I just took out the nuts, left one loose, you know, the bolts, left them loose. Nah, after trying the differential input stage, I put it back to the EF37A, modified the circuit somewhat, used a lot smaller resistor on the screen grid, on the screen grid decoupling, and changed it from 10U to 10N to roll off the base. Also did a similar thing here, put a 10N in instead of 100N, and I put a shelving filter. Well, it's just a filter, I don't know about shelving. It just basically rolls off the response from 3 hertz. And then I just tried a few other things, and then I threw everything at it. I tried elevating the chassis with the old 10 ohm, 2 diodes back, you know, reverse bias in relationship to each other with a 100N cap. Tried that at the same time as elevating the heater, DC heater supply, with a voltage divider. I mean, I had a you know, like a lead here, so I'm just sort of chucking stuff at it. What else did I try? Oh, I tried everything. Tried every damn thing. So what does it need? I'm pretty certain it's this. I've cited this wrong. See, the problem is with valve amps, we've got a big output transformers down here. Usually, you know, good sort of practice would be to put the mains transformer either on the top there, or at least as far away as you can from the input. And so what I did, because of the distribution of the weight, I thought, right, I'll put it there, you know, so it sort of balances better. And I think that's the issue. I thought that a screen would help. No, it doesn't. It's just not enough. Like I say, I can get the hum down to about less than a milliamp, but with the volume up, you know, to a good degree, you can really hear the hum. Not when the music's playing, but yeah, it's wrong. So that's got to come out. Either wind another transformer and put that on the top there, or move everything here and put it down here, which is basically starting again from scratch, more or less, isn't it? So yeah, that's what it needs, I think, because the other 2C34 amplifier that I made, that's what I did. I put the mains transformer here, and that one is quiet, no issue whatsoever. It's got a little bit of hum on the right hand channel, but not as so you notice. It's livable with, you know. Yep, so that's it. I'm going to put it aside for a while, go and do something else for a bit, and then when I'm feeling stronger, take it all apart, do it again. I don't know, sometimes I question my ability to build valve amplifiers, and fuck it, whatever. Anyway, nice sunshine out there. I shouldn't be in here pissing about a valve amplifier. I should be frolicking in the meadows. Thanks all very much for watching and sticking along through this interminable journey. Take care of yourselves. Ta-da for now. Taking a step back a little, if you want to find out where hum is getting in and where it, you know, you need to address that particular point, usually it's your first stage, because that traditionally has the most gain. So what I'm going to do here, I'm going to put my scope probe on. Jesus, well, okie dokie, well that wasn't planned. Obviously waving the scope probe around when you're not looking, when trying to film, is not a good idea.